We're going to pick up here solving radical equations. We're going to do these last few examples from the notes on yesterday. So if you're solving, what you want to do is you're trying to get the x on a side by itself, which means I want to move the 81 over by subtracting it. So I have x squared equals negative 81. And then what I want to do is I want to take the square root of both sides because you want to turn the x squared into just an x. So x squared turns into x, the square root of 81. Now, one thing that you have to remember when you are taking the square root and you're solving an equation, you always have to put this plus or minus symbol out front, always. Square root of 81 is 9, and remember that negative is going to turn into our I. For b, very similar, we want to start by subtracting the 72. And we'll get a squared equals negative 72. Take the square root of both sides. A squared turns into a. If we simplify the square root of 32, or 72, we want to think of the biggest number that goes in 72 that's a perfect square. So that's going to be 36 and 2. So then the square root of negative 36, don't forget that plus or minus symbol, is going to be 6i, and then we have our 2 there. For c, we're going to start by subtracting 1. Oops, I didn't mean to mark that out. All right, so we get 2x squared equals negative 4. Then we're trying, remember, you're trying to get the x squared by itself, so we want to divide by 2. So we get x squared equals negative 2. Now we're ready to take the square root of both sides. And x squared turns into x. Don't forget your plus or minus. Now, 2 is not a perfect square, but you can't leave that negative in the radical. You never, ever leave negatives in radicals. So the negative comes out, and remember, it always turns into an I. A negative inside a radical always turns into an I. So we get plus or minus I squared root of 2. For d, I'm going to start by subtracting 1. We'll get negative 3x squared equals 6. Then I'm going to divide by negative 3. And we'll get x squared equals negative 2. Take the square root. So this is basically where we ended up on problem C. Square root of x squared is x. You have to put the plus or minus symbol. If you don't, you will get points counted off, or if you select an answer without the plus or minus, it will be incorrect. Negative turns into I, and 2 just stays a radical because we can't simplify it. Okay, so solving radical equations, so still along the same lines, but just slightly different problems. If you have 2 square roots equal to each other, basically if you square both sides, you do the same thing to both sides, you'll get 3x equals x plus 6. And then just solve for x from there. So we'd subtract x. We'll get 2x equals 6. Divide by 2. X equals 3. All right. Now, we haven't seen this yet, but anything to a half power, this here, if it's to the half power, that is the same thing as square root of 2x equals the square root of x plus 5. So a half power is the same thing as a radical. Okay, a half power is the same thing as a radical. And so then if you square both sides, you'll get 2x equals x plus 5. We solve for x, so I'm going to subtract the x. 2x minus x is x. We'll get x equals 5. Okay, on C, remember a half, if it's raised to a half power, that is the same thing as a square root. But what I need to do is I need to move this to the other side by adding it. So I'm going to add it and move it over to the other side. So then it's going to look like 7x plus 6 equals the square root, or so square root of 7x plus 6 equals the square root of 9 plus 4x. Then if you square both sides, you just have 7x plus 6 equals 9 plus 4x. I'm going to subtract my 4x and get 3x, and then I'm going to subtract my 6 and get 3. and then divide by 3. So x equals 1. Same thing for D. I'm going to take this and I'm going to add it, move it to the other side. So I have the square root of 3x plus 2 equals the square root of 2x plus 7. Square both sides to make those radicals go away. And now we just solve for x. So I'm going to subtract 2x, which gives me x. I'm going to subtract the 2, and it gives me x equals 5. For E, I'm going to subtract the 2 because it's separate from the radical. And now I've got the square root of x plus 1 equals 2. Now this time both sides are not radicals, okay? So when I square both sides this time, this side turns into x plus 1. The radical goes away, but this side turns into a 4. So then when I simplify, subtract 1 and get x equals 3. For F, notice the radical is not all by itself. You want the radical by itself, so we have to move the 4. Being the 4 is attached to the radical, that means it's technically being multiplied. So we're going to divide by -4 to move it. And we'll get the square root of 6x plus 37 equals 1. So now when I square both sides, I'll get 6x plus 37 equals 1, because 1 squared is just 1. If I subtract 37, I'll get 6x equals -36. Divide by 6, and x equals -6. Okay? All right, so identifying equations with extraneous solutions. So sometimes when we check radical equations, the solution doesn't work. We call these types of solutions extraneous solutions. Okay, so what happens here is if I solve this one, I'm going to move my 8 to the other side because you always want to isolate the radical before you square anything. We'll get the square root of 3y equals -6. Then when I square both sides, I'll get 3y equals 36 because I'm squaring that -6, so it's going to turn to a positive. Divide by 3. And x is going to equal 12. Now, it is important to check your answers. I didn't check my answers on the first few, but we're going to start checking our answers now because I'm introducing extraneous solutions. So what happens here, when you take this answer and plug back into the original problem, I'm going to go back to my original problem right here. Square root of 3, oops, I changed it to x. There's a y, okay? So times 12 plus 8. I'm going to check to see that that equals 2. 3 times 12 is 36. Square root of 36 is 6. 6 plus 8 gives me 14. 14 does not equal 2. Okay, that does not work. So when that happens, we worked everything right. We worked out everything right over here. We did all the right work, but when you plug it back in, it doesn't work. And so that's what you call an extraneous solution. So from now on, it is important for you to check and make sure that your answers do work. So for B, if I subtract 6, I get negative square root of 2x equals 4. I'm going to divide by -1 because I'm going to get rid of that this negative right here. So I get square root of 2x equals -4. So now when I square both sides, that gives me 2x. This is going to, remember, we're squaring the -4. -4 times -4 is 16. Divide by 2, x equals 8. So if I check 8 to see if it works, and we'll see that it equals 10. 2 times 8 is 16. Square root of 16 is 4. 6 minus 4 is 2. 2 does not equal 10. So this is another example of an extraneous solution. Okay. Another way that you can find these answers is you can plug them in Desmos. And what you would do is you would type this in to one line. So this, you would do like y equals, this would be like your first equation. And you've got to do this one, you've also got to do like y equals 5. That would be your second equation. Okay? So if you type these into Desmos, then find the intersection of these. Okay? So when we do that, I'm going to try to insert a video here. So hopefully we'll see. Otherwise, I may have to just do a whole new video where you can see Desmos for these problems. Okay? So when you do that, you just find the intersection. All right? And if, okay, so use Desmos. We're going to use Desmos for these because it's important to utilize our Desmos. If there's no intersection, that means there is no solution. Okay? So you click on the intersection and find it. No intersection means no solution. Okay? So I'm actually going to do a separate video for this, and I'm going to be using these problems, and I will show you what I'm talking about when we're using Desmos. So we're picking up where we left off on this problem on example, on that example where I told you we were going to use Desmos. So as you can see, if you look up here at the top, I've got the two different equations typed in for y equals. And if you look on your graph, you've got the red graph and the blue graph, and they do not intersect. So what that means is, for this one, remember like we said, no intersection, no solution, this one is going to be no solution. And that's a symbol you can use for no solution. It's like a 0 with a slash through it. Okay? For 2, since it's set equal to 0, you can let this be one side. That can be like your y1, and this can be your y2. You set them equal, okay? So if we're gonna plug these in, let's see here. I'm just gonna change these. All right, so up here, we're gonna type in y equals, the square root is down here at the bottom, 4x plus 1. Make sure you hit your over arrow so you can get on the outside, because that minus 5 is not on the outside. And then we've got y equals 0 for your second one. Okay, so if you look at this one, you see that they intersect, and all you have to do is click on the intersection, and your x value is your answer. So 6 is going to be your answer. All right, so for the next one, we just plug these in. This would be one of the y's. This would be your other y. So this is like y1 and y2. These are what you would plug in into your Desmos. So y equals the square root of x minus 3. And then y equals the square root of x plus 5. Okay. And so for this one, we may have to go slide our graph way over to see where they intersect. Or we could just, we zoom out, we could probably get there a little bit faster. Okay, so let's see here, still not there. We'll zoom out again. Still trying to find that intersection. Okay, so sometimes when you keep looking, it's hard to find. So this one may be one that you want to do by hand. So if we just square both sides, we've got x minus 3 equals x plus 5. And so what happens is when we subtract the x's go away completely, and you're left with negative 3 equals 5. Well, that's not true. So that kind of confirms that these don't intersect, and we're going to get no solution for that one. All right, so moving on to number 4. So we have y equals the square root of, and I always like, anytime they use different variables, I still just like to stick with x. So there's one equation. And our second equation, y equals the square root of x minus 3. Okay. All right, so we look at these, and these look like they're never going to intersect. Okay, they kind of keep getting further, the lines keep getting further apart. So that one is no solution. Okay, remember, if something is raised to a half power, like right here, that is really the square root of x plus 3. Okay, so that's what we would type in here. So 5 square root of x plus 3 minus 1, make sure you put that 1 on the outside. And always put y equals. It's a very good habit to get into, to always put that y equals. So we've got the 5 square root x plus 3, and you could still raise it to the 1/2 power. That would still work in Desmos. Minus 1, there's one equation, and then we have y equals 24. Okay, so here's our intersection. I'm just zooming in. Okay, my intersections where the purple and black line cross. I just click on that, and my x value is going to be 22. So x equals 22. All right, same thing for here. Remember, these are just square roots. Square root of 3x equals square root of x plus 6. So I've got y equals square root of 3x, and y equals square root of x plus 6. Okay, if I zoom in, right there is going to be the intersection at 3. So you always use the x value. So x equals 3. Okay. For number 7, we just type those into Desmos. So I have the square root. So y equals the square root of x plus 21. Go to the outside, make sure that minus 1's on the outside. And I got y equals x. So I can zoom in here and see where these cross. Click on that. And our x value is 4. Okay, last one. Same thing, I'm just going to type it into Desmos. I've got x plus 3 on one side. And on my other side, I've got the square root of 33 plus 4x. Okay, and you can just zoom in. There's our intersection. Click on it. X equals 4. And so that's how you can use Desmos to help you solve radical equations.